Welcome back friends. So our today's topic is matter in our surroundings. In this video we will discuss about different type of matters and properties related to them. At last we will discuss about the exercise based on the chapter. Matter is defined as anything that has mass and occupies space. It's the stuff that makes up the universe and everything in it, from the smallest particles to the largest objects. Some of the examples of matter are drop of water, particles of sand, plants, stones and clouds. Physical nature of matter. Our matter is made up of very tiny particles which may be atoms or molecules. For example, 1 grain of salt has 1.2 into 10 to the power 18 atoms. The matter is made up of particles. The particles of matter are very small beyond imagination. These particles have space between them. For example, when we dissolve salt in water, salt particles get into spaces between water particles and we are not able to see them after they dissolve. Particles of matter are in continuous motion. This is because of the kinetic energy possessed by the particles which increases on increasing the temperature, and so particles move much faster. For example, when we light an incense stick agarbatti, we are able to smell it from another corner of the room because gas particles from incense stick have reached our nose. Next, particles of matter attract each other by attractive forces. The attractive forces bind the particles of matter in a single body and lead to particles arrangement. The particles of matter have a force acting between them. For example, if we struck iron nail and chalk with a hammer, it is easier to break chalk but not iron nail because the force of attraction is higher in particles of iron nail as compared to chalk. Next, the various states of matter. The matter around us exists in 3 physical states on the basis of physical properties. First, solid states such as stone, wood, rubber, plastic. Second, liquid states such as water, oil, vinegar, milk. Third, gaseous states such as oxygen, carbon, hydrogen. Now let's discuss about the physical properties of matter. First, color. It is the appearance of a substance. For example, copper is reddish-brown in color. Second, mass. It is the amount of matter present in a sample. It is measured in kilograms or grams. Third, volume. It is the space taken up by matter. It is measured in liters or cubic centimeters. Fourth, density. It is the mass per unit volume and measured in kilogram per meter cube or gram per centimeter cube. Fifth, melting point. It is a temperature at which a solid turns to liquid. Sixth, boiling point. It is the temperature at which a liquid turns into vapor. Seventh, solubility. It is the ability to dissolve in a liquid like water. Eighth, conductivity. It is the ability to let heat and electricity pass through. Ninth, malleability. It is ability to be pressed into sheets. Comparison of the characteristics of 3 states of matter. First, interparticle space. In solid space is very small, in liquid space is comparatively large, and in gases the spaces are very large. Second, interparticle forces. In solids, it is very strong, in liquids it is weak, and in gases it is very weak. Third, nature. Solids are very hard and rigid. Liquids possess the property of fluidity and can flow. Gases possess the property of fluidity and can flow in all directions. Fourth, compressibility. Solids can't be compressed. Liquids can be slightly compressed whereas gases are highly compressible. Fifth, shape. Solids have definite shape. Liquids and gases have indefinite shape. Sixth, volume. Solids and liquids have definite volume but gases have indefinite volume. Seventh, kinetic energy. In solids, it is low. In liquids it is comparatively high. Whereas, in gases it is very high. Eighth, density. Density of solid is high. Liquids have density less than solids. Gases have very low density. Moving towards the next topic. Change in states of matter. Matter can exist in different states, primarily solid, liquid and gas. These states can be interconverted by altering temperature and pressure. Effect of temperature. Heating a substance increases the kinetic energy of its particles, causing them to move more vigorously and increasing the distance between them. This weakens the intermolecular forces, allowing the substance to change its state. Melting. Conversion of solid into liquid. When a solid is heated, its particles gain enough kinetic energy to overcome the forces holding them in a fixed arrangements, allowing them to move freely and form a liquid. The fixed temperature at which this occurs at atmospheric pressure is called the melting point. For example, ice melts into water at 0 degrees Celsius. Next, freezing or solidification. Conversion of liquid into solid. Cooling a liquid causes its particles to lose kinetic energy and slow down. The intermolecular forces become stronger, pulling the particles closer and arranging them in a fixed pattern, resulting in a solid. For example, water freezes into ice at 0 degrees Celsius. Boiling or vaporization. Conversion of liquid into gas. As a liquid is heated further, its particles absorb enough energy to overcome the intermolecular forces holding them in the liquid state and escape into the gaseous phase. The specific temperature at which this occurs at atmospheric pressure is called the boiling point. For example, water boils into steam at 100 degrees Celsius. Next, condensation. Conversion of gas into liquid. When a gas is cooled, its particles lose energy, slowing down and drawing closer together due to intermolecular forces. This leads to the formation of a liquid. For example, water vapor condenses into water droplets. Sublimation. It is a process in which some solids directly changes into a gaseous state without first becoming a liquid upon heating. For example, camphor sublimes readily when heated. Next, deposition. It is the process where a substance in a gaseous state directly transforms into a solid state without becoming a liquid first. For example, formation of frost on a cold surface. Next, moving to the next topic. Phase transformation. It is a fundamental concept in physics where a substance changes from one state of matter to another solid, liquid, or gas. This change occurs when the substance absorbs or releases heat energy, altering the arrangement and motion of its particles. For instance, when ice melts into water or water vaporizes into steam, the particles gain energy and move more freely. Conversely, when steam condenses into water or water freezes into ice, the particles lose energy and become more ordered. Next, moving to the next topic. Phase transformation. It is a fundamental concept in physics where a substance changes from one state of matter to another solid, liquid, or gas. This change occurs when the substance absorbs or releases heat energy, altering the arrangement and motion of its particles. For instance, when ice melts into water or water vaporizes into steam, the particles gain energy and move more freely. Conversely, when steam condenses into water or water freezes into ice, the particles lose energy and become more ordered. Second effect of change of pressure. Applying pressure on a substance can force its particles closer together, increasing the intermolecular forces and causing a change of state. Increasing pressure and decreasing temperature can cause gases to liquefy, as seen with LPG. High pressure can also cause liquids to solidify in some instances. Evaporation. It is the process where a liquid like water turns into a gas as water vapor and enters the air. It happens when the liquid's molecules gain enough energy, usually from heat, to break free from the liquid's surface and become gas. Factors that affects the rate of evaporation are surface area, change in temperature, humidity and wind speed. An increase in surface area. Greater is the surface area, more is the rate of evaporation. This is because only the particles on the surface of the liquid get converted into vapors. For example, we often spread the wet clothes in air to dry them. By doing so, the surface area available for evaporation of water increases and hence the clothes get dried up soon. An increase in temperature. The rate of evaporation increases with increase in temperature due to increase in kinetic energy of liquid particles. This is because, due to increase in kinetic energy, the liquid particles can more easily overcome the forces of attraction of neighboring particles on the surface of liquid and hence can more easily get converted into vapors. For example, evaporation of a liquid occurs at a faster rate in summer than in winter. Decrease in humidity. Humidity is the amount of water vapor present in air. The air around us can hold only a certain definite amount of water vapors at a particular temperature. If humidity of air is already high, i.e. the amount of water vapors in the air is already high, then air can hold only a little more amount of vapors to reach that optimum level. Therefore, the rate of evaporation decreases. For example, we sweat a lot in hot and humid weather than in dry weather because air already has high amount of water vapors in humid and hot weather. Therefore, the sweat liquid that comes out of our skin does not evaporate and remains sticking to our body. Increase in the speed of wind. The rate of evaporation increases with increase in wind speed. This is because, due to increase in wind energy, the liquid particles move away with the wind and thus decreasing water vapors in the surroundings. For example, wet clothes dry faster on a windy day due to increase in wind speed and thereby increasing the rate of evaporation. Some measurable quantities and their units. एक stone temperature, its unit is Kelvin and abbreviated as K. Second, length, its unit is meter and abbreviated as m. Third, mass, its unit is kilogram and abbreviated as kg. Fourth, weight, its unit is Newton and abbreviated as N. Fifth, volume, its unit is cubic meter and abbreviated as kg meter cube. Sixth, density, its unit is kilogram per cubic meter and abbreviated as kg per meter cube. Seventh, pressure, its unit is Pascal and abbreviated as PA. Now moving towards the chapter-based exercise. Question: first, convert the following temperature to the Celsius scale. To convert the temperature from degree Celsius to Kelvin, we have to add 273 with degree Celsius, and to convert Kelvin to degree Celsius, 273 is subtracted from Kelvin. Part A: 293 Kelvin. 293 minus 273 is equal to 20 degrees Celsius, so 293 Kelvin is equal to 20 degrees Celsius. Part B: 470 Kelvin. 470 minus 273 is equal to 197 degrees Celsius, so 470 Kelvin is equal to 197 degrees Celsius. Second question: convert the following temperatures to the Kelvin scale. Part A: 25 degrees Celsius. 25 plus 273 is equal to 298. Therefore 25 degrees Celsius is equal to 298 Kelvin. Part B: 373 degrees Celsius. 373 plus 273 is equal to 646. Therefore 373 degrees Celsius is equal to 646 Kelvin. Third question. Give reason for the following observations. Part A. Naphthalene balls disappear with time without leaving any solid. Solution. Naphthalene balls disappear without leaving any solid because they undergo sublimation, changing directly from solid to gas. Part B. We can get the smell of perfume sitting several meters away. Solution. We can smell perfume from a distance because perfume particles diffuse through the air, spreading out and reaching our noses. Fourth question. Arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. Solution. Increasing order of forces of attraction. Oxygen gas, then water liquid, then sugar solid. Question 5th. What is the physical state of water at 25 degrees Celsius, 0 degrees Celsius and 100 degrees Celsius? So the water is in liquid state at 25 degrees Celsius, solid at 0 degrees Celsius and steam or gas at 100 degrees Celsius. Sixth question. Give reason to justify why water is liquid at room temperature. So the answer is, because its freezing point is 0 degrees Celsius, and its boiling point is 100 degrees Celsius, so it's within the liquid range at room temperature. Secondly, it has a fixed volume but takes the shape of its container. Next part, why an iron almirah is a solid at room temperature. So, an iron almirah is a solid at room temperature because its melting point is very high, far above room temperature. Secondly, it has a fixed shape and volume. Question 7th. Why is ice at 273 K more effective in cooling than water at the same temperature? This is because it absorbs latent heat from the surroundings to change its state from solid to liquid, whereas water at the same temperature doesn't undergo a phase change. Next, question 8. What produces more severe burns, boiling water or steam? Because it has more heat energy than boiling water. When steam comes into contact with skin, it releases this extra energy, causing more damage. In the following diagram, showing the change in state, name A, B, C, D, A and F. As, on increasing heat and decreasing pressure, the solid changes to liquid state and liquid changes to gaseous state. Whereas, on decreasing heat and increasing pressure, gas changes to liquid state and liquid changes to solid state. So, point A is melting. Point B is vaporization. Point C is condensation. Point D is solidification. Point A is sublimation. Point F is deposition. Now some of the additional questions based on chapter. First question. Which of the following are matter? Chair, air, love, smell, hate, almonds, thought, cold, lemon water, smell of perfume. So, among the following, chair, almond, lemon, water, air are matter. Next question is, why the smell of hot sizzling food reaches you several meters away, but to get the smell from cold food you have to go close? It's because hot food particles have more kinetic energy, allowing them to diffuse faster and travel farther as increased temperature increases the rate of diffusion, making the smell more noticeable from a distance. Whereas cold food particles have less kinetic energy, so they diffuse slower and don't travel as far, requiring you to get closer to smell them. Third question. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? So, this observation shows that matter is not continuous, but rather composed of particles with space between them. The diver is able to cut through water because the particles are able to move apart, allowing the diver to pass through. Next, what are the characteristics of the particles of matter? So, the particles of matter have the following characteristics. First, they have space between them, that is intermolecular space. Second, they are in constant motion, that is kinetic energy. Third, they attract each other, that is intermolecular forces. Fourth, they have different arrangements depending on the state of matter, that J solid, liquid, or gas. Next one, arrange air, exhaust from chimneys, honey, water, chalk and etain in order of increasing density. So on increasing order of density, the following substances are placed as air, exhaust from chimneys, cotton, water, chalk, honey, and iron. Next question, tabulate the differences in the characteristics of states of matter. First, solid has fixed shape, fixed volume. It has high density, low compressibility and can't flow. Then, liquid do not has fixed shape but has fixed volume. Its density is medium, having low compressibility but it can flow. Third, gas do not have fixed shape and volume. Its density is low but compressibility is high. Gas can flow in each direction. Next one, comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. Solution: egg stone. Solids maintain their shape due to strong intermolecular forces. Second, gases are highly compressible due to large intermolecular spaces. Third, liquids and gases can flow due to particles' ability to move past each other. Fourth, gases expand to fill the containers due to particles' random motion. Fifth, solids have a fixed shape, while liquids take the shape of their container, and gases fill their container. Sixth, particles in gases have the highest kinetic energy, followed by liquids, and then solids. Seventh, generally, solids have higher density than liquids, which have higher density than gases. Next, give reasons for the following. Egg stone. A gas fills completely the vessel in which it is kept. This is because gas particles are free to move and spread out, occupying all available space. Second, a gas exerts pressure on the walls of the container. This is due to collisions between gas particles and the container walls. Third, a wooden table should be called a solid. This is because it has a fixed shape and volume, and its particles are closely packed. Fourth, we can easily move a hand in air, but to do the same through a solid block of wood we need a karate expert. It's because air particles can move apart easily, but moving through a solid block of wood requires breaking strong intermolecular forces, making it difficult without sufficient force. Next, liquids generally have lower density as compared to solids. But you must have observed that ice floats on water. Find out why. It's because density of ice is lower than that of liquid water. This is due to the unique crystal structure of ice, which creates more space between molecules, making it less dense.